We've learned a couple ways to make amines in previous chapters. First, we learned how to make them from alkyl halides, and second, we learned how to make them from carboxylic acids. In this video, and in this exercise, 23.10, we're going to review those two ways of making amines. And because amines are so useful in drugs, and in making hormones or neurotransmitters like dopamine or serotonin, you'll see how powerful those two methods that we've already learned can be. So, in each of these molecules, and they give us several amines, we're going to see how to make them in two different ways. Once using an alkyl halide, and then again using a carboxylic acid. So I'm going to draw these molecules separately for each of these methods. And we'll think about how we can synthesize these from alkyl halides or carboxylic acids. Okay, so let's do retrosynthesis. What we're starting with here, what they give us, is the molecule we want. So we have to work backwards. How can we make this thing that we want? So let's draw a retrosynthetic arrow that has those two parallel lines and sort of the arrowhead that uses both of them. Remember, what this means is I can make this from this other thing. So we'll think this way, and then we're going to reverse the arrow and come up with our specific recipe after we get the carbon chain that we need. Now, when you use an alkyl halide, when you see the words alkyl halide, you should think, okay, carbon chain, that's the alkyl, and the halide is a halogen. So that's chlorine, bromine, iodine. Really, those are good leaving groups. Remember that when the halogens are represented by a symbol altogether, it's a capital X. Capital X means chlorine, bromine, or iodine in organic chemistry. So alkyl halides have this good leaving group, and amines can come in and attack them through a substitution reaction. You can substitute a group that has a nitrogen in it with a halogen. And the group that can come in as a nucleophile that we've learned about already is a cyano group, a nitrile, that has a nitrogen in it. It can come in as a nucleophile, attack the carbon, kick the leaving group off, and then you form a bond between the cyano group and the carbon, and so it becomes a nitrile. After that, you can use lithium aluminum hydride, followed by water, and that reduces that to an amine. So it takes, remember that lithium aluminum hydride is a source of hydrogen nucleophiles. And so the hydrogen nucleophiles attack this carbon over and over, and then the nitrogen gets protonated, so that you end up replacing these two bonds between the carbon and the nitrogen with bonds to hydrogens. Hydrogens in lithium aluminum hydride and water. So we have a two-step method for creating amines from alkyl halides. The first step is to take the alkyl halide that you have and react that with a cyano nucleophile. You do an SN2 reaction, and you get a nitrile, and then you reduce the nitrile, and that gives you your amine. Now notice that in that process, you end up adding a carbon in addition to the nitrogen. So when you look at the amine that you have, and you're trying to think backwards, you can look at this and say, this is what we're going to add, a carbon and a nitrogen. So this nitrogen and the carbon it's attached to are going to come from the cyano group. So what I want is just the rest of the molecule. So if you took that, what we'll do is erase the nitrogen, and we'll erase that carbon there, and where the carbon was, we'll have a leaving group. So notice we only have 3 carbons here now. the fourth carbon will come from the cyano group. And so this is the alkyl halide we can use. Okay, so now that we sort of thought backwards, let's fill this in and think forwards. If we have this alkyl halide, we can treat it with a cyano nucleophile. So really that's Cn minus, where the carbon and the nitrogen are triple bonded to each other. But oftentimes the negative charge on that carbon is being stabilized by a cation like sodium. So you might see that written in as NaCN. That's this, really a cyano nucleophile. That's your first step. That does an SN2 reaction, so that you have the nitro group, or the cyano group, the nitrile, replacing or substituting the bromine, so an SN2 reaction, and then you reduce it first with lithium aluminum hydride, and then with a water wash, and that gives you your amine. So we have our fourth carbon here, and then the NH2. So that overall, the whole recipe, and you notice this is what we wanted. So overall, the whole recipe here is first, we'd have this molecule, we would treat it with NaCN, second, lithium aluminum hydride, and third, water. And that would give us the product that we want, this here. Okay, this is a little crowded. Let me make some rooms to help clarify that. So I'll bring this down here. Okay, so that would be our synthesis. That would be how we can make that amine from an alkyl halide, using a cyano group and then lithium aluminum hydride. Now, there is another way to do this. We can make this from a carboxylic acid. And the way we learned how to do that was, if we compare this, so if we're sort of using retrosynthesis, we're thinking, okay, here's our product. We can make that from, so we draw a retrosynthetic arrow. What can we can make this from this other thing. What will that other thing be? Well, we can make it from a carboxylic acid. And when you do that, the number of carbons doesn't change. So you would take whatever carbon the amine is on, and you would erase the amine and redraw and draw in a carboxylic acid. So for example, we could take this amine, look, notice the carbon that the nitrogen is on, erase the amine, and where it was, put an OH, and next door have a double bond to an oxygen. So you turn it into a carboxylic acid. Okay. Oops. Well, one thing is we have to get an NH2 there. But we can't just treat this with ammonia. We cannot just treat this with ammonia because this is a base, this is an acid, it will just do a neutralization reaction. So first we have to turn this carboxylic acid into a carboxylic acid derivative that is not an acid. And so the first step for that would be using thionyl chloride SOCl2 to turn this into an acid chloride. So that would replace the OH with a Cl, as we've discussed in previous chapters. Then you can treat that with excess ammonia and do a nucleophilic acyl substitution. The chlorine is an awesome leaving group, and the amine will come in as a nucleophile. So that you'd have the same molecule, but instead of a chlorine, you'd have the nitrogen that came in, Notice this only has 2 hydrogens. That's why you need excess, because a second equivalent of this will steal the 3rd hydrogen from that nitrogen there. And you can turn this amide into an amine, the product that we want, by doing a reduction. Notice 2 bonds to oxygen here, no bonds to oxygen there, so that is a reduction, and that would be using lithium aluminum hydride. And you use excess, and then followed up with a water wash. And we'll see that this is the procedure in general for turning a carboxylic acid into an amine. So we could make this amine from this carboxylic acid if first we turn the carboxylic acid, we turn this specific carboxylic acid into an acid chloride using thionyl chloride. Then we turn the acid chloride into an amide using excess ammonia. Then we reduce the bonds to oxygen using a strong reducing agent like lithium aluminum hydride. You'll want to use excess of it because we have to reduce that carbon twice. We have to get rid of 2 bonds, replace 2 bonds to oxygen with bonds to hydrogen, so excess, and then just do a water wash to stabilize the charges you created there. And so this synthesis here would be the way that you can make this amine from that carboxylic acid. Okay, let's think about those 2 methods again in this next exercise with a slightly different molecule. And I encourage you to look at this molecule, and if you even pause the video, compare this molecule with something like dopamine or adrenaline. They're not the same, but they're similar, and so you could see how you could start to create or make those neurotransmitters or hormones in a laboratory using these 2 methods. So first let's start out with the alkyl halide. So how can we make this from an alkyl halide? Okay, the first thing you want to do, we're going to do this using a cyano group like we saw in the previous exercise. So the question is, how can we make this from, what would we make this from? So this retrosynthetic error says, we can make this from what? What do we need? Okay, we're going to make this from an alkyl halide by doing an SN2 reaction with a cyano group. The carbon triple bonded to a nitrogen, and the carbon has a negative charge on it. That means that we're going to be adding a carbon and a nitrogen. Oh, carbon and a nitrogen. So we're going to be adding these 2 things. So when we're trying to think about what alkyl halide we need to make this from, you would erase the nitrogen, and you'd erase that carbon there. And where the carbon was, you would replace it with some sort of a leaving group. I'm going to use bromine, but it could also be chlorine or iodine. Notice that this is not a carbon anymore, it's a bond to that bromine. So we can take this alkyl halide, do an SN2 reaction. So if we treat it with sodium cyanide, remember that cyano group with the full negative charge on the carbon can attack the carbon that has the leaving group, kick it off, and turn this into carbon triple bonded to the nitrogen. So you can see how our leaving group got replaced by our nucleophile in that step. And then we just have to replace these bonds between the carbon and the nitrogen with bonds to hydrogen, like we have here. So we can do that, create more bonds to hydrogen by doing a reduction. What we're reducing are the bonds to an electronegative element. Nitrogen is an electronegative element. We're going to reduce the bonds to that by replacing them with bonds to hydrogen using a strong reducing agent. So you'd have excess lithium aluminum hydride followed by a water wash. And these hydrogens in those molecules will be the hydrogens that replace bonds, the bonds between the carbon and the nitrogen. So you have hydrogens here, those, and the ones that are on the nitrogen come from the lithium aluminum hydride in the water. So overall, you could make this amine from an alkyl halide doing an SN2 reaction by first taking this alkyl halide, reacting it with sodium cyanide, following that would give us the nitrile, and then following that up with a strong reducing agent like excess lithium aluminum hydride, followed by a water wash. I'm going to erase this here so that we can see the overall change. This would be a way to synthesize that amine using an alkyl halide. Okay, let's try to make the same amine, but from a carboxylic acid. So if you want to make this amine, you could make it from, so we'll use a retrosynthetic arrow, you can make it from what carboxylic acid? To predict the carboxylic acid you need in order to make this, take the bond to the nitrogen, erase the nitrogen, and replace it with an OH. And the carbon that had the nitrogen on it, put a carbonyl there. So the carbon that had the nitrogen on it turns into a carboxylic acid. That is the carboxylic acid we need. Notice the number of carbons is the same in that molecule, in the final molecule, the molecule that we start with as in the final molecule. So we're going to take this carboxylic acid, and first we want to get the nitrogen in there. We're going to get it in there using ammonia, but we can't react ammonia with a carboxylic acid because this is an acid and ammonia is a base, and H3 is a base. And so they'll do a neutralization reaction instead of a nucleophilic acyl substitution. So first we have to turn this into something that's not acidic, and that would be an acid chloride. And that also has the advantage of being the most reactive carboxylic acid derivative, so it'll increase the efficiency of the reaction. So if we can do that, you turn a carboxylic acid into an acid halide, or an acid chloride, using thionyl chloride, SOCl2. Once you have that, you can treat it with excess ammonia, excess NH3, drain cleaner, and that'll do a nucleophilic acyl substitution where the chlorine leaving group will be replaced by the nitrogen nucleophile. And you'll notice there's one less hydrogen here. The nitrogen has 2 hydrogens instead of 3 because the second equivalent of ammonia ripped it off in a proton transfer. And then last, we can turn this amide, that's where you have an amine bonded to a carbonyl. We can turn that amide into an amine by doing a reduction. After all, we have 2 bonds to oxygen here. We don't have any bonds to oxygen there. We need to reduce the number of bonds to oxygen, so we do a reduction. And so we can use a strong reducing agent. We'll use excess because we want to reduce 2 bonds, not just 1. So excess lithium aluminum hydride, and then followed up with a water wash. So that overall, to make this transformation happen, we can create this amine from a carboxylic acid by first turning the carboxylic acid into an acid chloride. Once you have the acid chloride, you can treat it by adding thionyl chloride. Once you have the acid chloride, you can react it with excess ammonia to turn it into an amide. And then you can reduce the amide using excess lithium aluminum hydride, followed by a water wash. And so this would be a way you can synthesize that amine that they gave us from a carboxylic acid. Okay, Let's try C, and I think the C is the last one here, so let's try C. We'll do both of these methods one more time. First, we'll take the molecule we have, and we want to think, how can we make this from an alkyl halide? Well, we can do that. So if we have this molecule, we could make it from, we draw a retrosynthetic arrow. We have this, we can make it from this other molecule. What molecule? It's going to be an alkyl halide, but we're going to do that by doing an SN2 reaction with a cyano group, a carbon triple bonded to a nitrogen. That means that we're going to be adding a carbon and a nitrogen. So take the nitrogen in the original molecule and the carbon next to it. Those are both going to come from a cyano group, so we want to erase those. And where the carbon was, you'll add a leaving group. Notice this is not a carbon anymore, it's a bond to the bromine. We removed the carbon there. Now I'm using bromine, but you could just as well use chlorine or iodine. So that's the alkyl halide we'd want to start with. So take that alkyl halide, and first thing, we're going to want to react that with sodium cyanide, NaCN, and that Cn is really a carbon triple bonded to a nitrogen with a lone pair and a full negative charge. That attacks this carbon that has the leaving group on it, kicks the leaving group off, and ultimately the leaving group will get replaced by the nucleophile. So we'll take this molecule here, erase the leaving group, and where it was, add in the nucleophile. So now we have the carbon and the nitrogen that we want. We just want to replace the bonds between them with bonds to hydrogens. And so we want to replace bonds to an electronegative element with bonds to hydrogens. In other words, we want to reduce the number of bonds to an electronegative element. We want to do a reduction. So we can use a strong reducing agent, so excess lithium aluminum hydride, and excess, so that, because we want to reduce more than one bond here, and then follow it up with water. And what we'll end up with is the molecule that we want. The hydrogens bonded to the nitrogen and also bonded to the carbon there. Those come from the lithium aluminum hydride hydrogen nucleophile and from water also. So that overall, you could make this transformation happen. You can make this amine from an alkyl halide. First, by figuring out what alkyl halide you need, and then treating the alkyl halide with sodium cyanide, that would give us the nitrile, and then follow that up with a strong reducing agent, excess lithium aluminum hydride, and then a water wash. And that would give you your product. I'm going to erase these mechanistic details I have here so you can see what this looks like overall. So that would be our synthesis. Okay, let's try to make that same molecule, but from a carboxylic acid. So if we have if this is the amine we want, how could we make that? We could make that from, that's what this retrosynthetic arrow is talking about. And let's think about the carboxylic acid we would need. So you take your amine, and the carbon that has the amine on it is the carbon that will have the carboxylic acid on it. So you erase the amine, put an OH where it was, and next to it have a double bond to an oxygen. And that's the carboxylic acid that we need. So what this is saying is we can make this amine from this carboxylic acid. This retrosynthetic arrow is telling us that. So let's take our carboxylic acid. The first thing we do, well, we know we need a nitrogen to come in here, but we can't just treat this with ammonia, because this is a base, this is an acid, so they'll just do a neutralization reaction. They'll do a proton transfer and instead of a nucleophilic acyl substitution. So the first thing we have to do is turn the carboxylic acid into a molecule that's not acidic. We can do that and make our reaction more efficient by turning that into an acid chloride, the most reactive of the carboxylic acid derivatives. and we don't have to worry about that acidic hydrogen anymore. So we treat that with thionyl chloride. SOCl2, that's what creates that transformation. Next, once we have that awesome leaving group, we can replace the chlorine leaving group with the nucleophile we want, the nitrogen, by adding excess ammonia, NH3. So that's going to be our nucleophile, and we can do a nucleophilic acyl substitution, where we substitute that leaving group with the nucleophile that came in. Notice that it only has 2 hydrogens instead of 3. The second equivalent of ammonia, that's why we have excess, the second equivalent did a proton transfer and took a hydrogen off of this to stabilize the charge that would otherwise be on it. So now we almost have the molecule we want. If you compare the molecule we have, this amide, this is an amide, an amine with a carbonyl next to it, an amine bonded to a carbonyl, it's almost the same as the amine that we want. The difference between these is that the amide has 2 bonds to an electronegative element and the amine does not. In other words, we want to reduce the number of bonds to an electronegative element. We want to do a reduction. So we could use a strong reducing agent like excess lithium aluminum hydride, and that strong reducing agent and we need excess because we're trying to get rid of 2 bonds to the oxygen. And the strong reducing agent will replace the bonds to the oxygen with bonds to a hydrogen. And then we just follow that up with a water wash. And the bonds to the hydrogen that we have here on the carbon, on the nitrogen and on the carbon, those hydrogens are coming from lithium aluminum hydride and water. Both of those in the mechanism. And we've seen that mechanism before in a previous chapter. So overall, we can make this transformation happen first by figuring out what carboxylic acid we need. And for that, you just erase the amine, fill it in with an OH, and the carbon bonded to it has a carbonyl. Then treat it with thionyl chloride to turn it into an acid chloride. Once you have the acid chloride, turn it into an amide using excess ammonia, and then reduce the bonds to the electronegative oxygen. So you use first excess lithium aluminum hydride, and then a water wash. And that recipe will create this transformation. You'll be able to turn a carboxylic acid into an amine. So hopefully this video helped you remember 2 of these ways that we learned to make amines separately in previous chapters. And these were in the carboxylic acid derivative chapter. We can make an amine from an alkyl halide using a cyano group, or we can make an amine from a carboxylic acid by doing a nucleophilic acyl substitution, a couple of them, and then a reduction.